Hello students, welcome to all. This is Dr. Vigneshwar Maika, lecturer in geography, Government Degree College for Women's, Hyderabad. Today we are going to discuss about the earthquakes part 2 video. In the previous video of earthquakes part 1, we have gone with introduction to earthquakes, definition of the earthquakes, causes of earthquakes, earthquakes based on the depth focus, distribution of earthquakes, and a Richter magnitude scale. And today, and that is in this session, the points to be covered in part 2 video are Richter magnitude scale, earthquake zones of India, effects of earthquakes, and tsunami waves, and finally the 2004 Indian Ocean Tsunami wave. In the previous video, as a part of Richter magnitude scale, we have been discussing about the magnitude and the scale, description, impact, frequency of earthquakes taking place. If the magnitude is 5.0 to 5.9, this earthquake is termed as moderate earthquake. The causes or impacts would be damage of varying severity to poorly constructed buildings, at most none to slight damage to all other buildings, felt by everyone if this takes place. Every year, around 1,000 to 1,500 earthquakes takes place. And if the magnitude is 6.0 to 6.9, the earthquake is termed as the strong earthquake. If we come to the impacts, damage to a moderate number of well-built structures in populated areas. Earthquake-resistant structures survive with the slight to moderate damage. Poorly designed structures receive moderate to severe damage, felt in wider areas up to hundreds of kilometers from the epicenter area, and strong to violent shaking in the epicenter area takes place. At an average, 100 to 150 earthquakes takes place per year, and 2011 Christchurch earthquake, which received 6.2 magnitude and the Richter scale, is the best example. If the magnitude is 7.0 to 7.9, then this earthquake is termed as a major earthquake. Impacts would be damage to most buildings, some to partially or completely collapse or receive severe damage. Well-designed structures are likely to receive damage also. This would be felt across great distances with major damage mostly limited to 250 kilometers from the epicenter area. Around 10 to 20 earthquakes takes place per year. Examples: 1819 Ran of Kutch earthquake and 2001 Gujarat earthquake. If the magnitude on the scale is 8.0 to 8.9, this earthquake is termed as the great earthquake. The impacts would be major damage to buildings, structures likely to be destroyed, will cause moderate to heavy damage to sturdy earthquake resistant buildings also. Damaging would be in larger areas, and it would be felt in extremely large regions. The frequency is one per every year. Test examples are 1556 Shanxi earthquake in China and 1950 Assam earthquake, Assam Tibet earthquake, and in 2008 Sichuan earthquake and 2010 Chile earthquake. If we take the magnitude 9.0 and greater, it is also termed as a great earthquake, and impacts would be at or near total destruction, and the damage would be very severe, and sometimes the buildings may be collapsed. Heavy damage and shaking extend to distant locations from the earthquake epicenter. The permanent changes will take place in the ground topography here and there. One per 10 to 50 years will take place such type of earthquakes on the surface. In 1960, Valdivia earthquake in Chile, which recorded magnitude 9.4 to 9.6. 1964 Alaska earthquake in Canada, in America, recording magnitude about 9.2. And in 2004, a great Indian Ocean earthquake ranging between 9.1 to 9.3 led to the tsunami also. And in 2011, the Hoku earthquake in Japan, recording the magnitude of 9.1%. Coming to the next section, the earthquake zones of India. Earthquake zones, which are also known as the seismic zones in India, subcontinent is divided into 4 seismic zones, 2, 3, 4 and 5. Based on scientific inputs related to the seismicity, earthquakes occurred in the past in tectonic setup of the region. Previously, earthquake zones divided into 5 zones with respect to the severity of the earthquakes, but Bureau of Indian Standards has grouped the country into 4 seismic zones. The first and the second seismic zones were unified. The Bureau of Indian Standards is the official agency for publishing the seismic hazard maps and codes. It has brought out versions of seismic zoning map, a 6th zone map in 1962, a 7th zone map in 1966, and a 5th zone map in 1970 and 1984. The picture on the screen discloses to you about the seismic zones map of India that is prepared in 2002. About 59% of the land area of India is liable to the seismic hazard damages. And coming to the seismic active zones, or the seismic zones are earthquake zones. The first is the seismic zone 2. Area with minor damage, that is causing damages to structures with fundamentally periods greater than the 1 second. Earthquakes corresponding to intensities 5 to 6 of the M scale, modified Mercalli intensive scale. It covers the areas which are not covered by all the 3 seismic zones discussed below. Seismic zone 3 or the earthquake zone 3, the moderate damage corresponding to intensity 7 of modified Mercalli intensity scale. It comprises Kerala, Goa, Lakshadweep Islands, and remaining parts of the Uttar Pradesh, Gujarat, and West Bengal, parts of Punjab, Rajasthan, Madhya Pradesh, Bihar, Jharkhand, Chhattisgarh, Maharashtra, Orissa, Andhra Pradesh, Tamil Nadu, and Karnataka also. In the seismic zone 4, major damage corresponding to the intensity 7 and higher of the mm scale. It covers remaining parts of Jammu and Kashmir and Himachal Pradesh, National Capital Territory of Delhi, Sikkim, northern parts of Uttar Pradesh, Bihar, and West Bengal, parts of Gujarat and small portions of Maharashtra near the west coast, and even Rajasthan state also. Zone 5, the area determined by seismically of certain major fault systems is seismically the most active region and comprises of entire northern India, parts of Jammu and Ladakh capital territory union territories, Himachal Pradesh, Uttaranchal, Rann of Kutch region and Gujarat, part of North Bihar, Andaman and Nicobar Islands. Earthquake zone 5 is the most vulnerable to earthquakes, where historically some of the countries most powerful shock have took place. Earthquakes with the magnitude in excess of 7.0 have took place in these areas and have had intensity higher than 9.0 on the magnitude Richter magnitude scale. Now we move with the effects of the earthquakes. After the occurrence of the earthquakes, the following important impacts: shaking and ground rupture, landslides and avalanches, fires, soil liquefaction, tsunami, floods, etc. And let us discuss about each of these in detail. The one, shaking and ground rupture. Shaking and ground rupture results in severe damage to the buildings and their rigid structures. Ground rupture, that is crack along the fault region, is a major risk for low engineering structures on the surface such as dams, bridges, and natural power stations. And the second is landslides and avalanches. After the earthquakes, along with severe storms, volcanic activity, coastal wave attack, and wildfires can produce slope instability leading to landslides, a major geological hazard. And even Chandra region and also in the mountain areas, avalanches also take place due to the effect of the earthquakes. Third is the fires. Earthquakes can cause fires by damaging electrical power, gas line, collapse. More deaths in the 1906 San Francisco earthquake in America, which were caused by fire than by the earthquake itself. And the fourth is soil liquefaction. This occurs when water saturated soil temporarily loses its strength and transforms from a solid to a liquid state. The soil liquefaction may cause rigid structures like buildings and bridges to tilt or to sink. The next is tsunami. The megathrust earthquakes can produce long wavelength, long period sea waves due to abrupt movement of large volume of water. In the next paragraph, we will look at the characteristics, properties of the tsunamis in world. The sixth effect is floods. Floods may be secondary effects of the earthquakes if the dams are damaged after the earthquake takes place. Earthquakes may cause landslips to dam rivers, which collapse and cause huge floods in some times. And now we will look at tsunami and their characteristics. Even tsunami is a Japanese word for referring a wave. A tsunami is a series of very long wavelength waves in large water bodies like seas or large lakes or oceans caused by a major disturbance above or below the water surface due to the displacement of a large volume of water. They are sometimes referred to as tidal waves because of long wavelengths, although the attractions of the moon and the sun play no role in the formation of the. Now the mechanism of tsunami waves. Megathrust earthquakes cause a sudden displacement of seabed sufficient to cause the sudden rising of a large body of water. As the subjecting plate plunges beneath the less dense plate, stresses build up. The locked zone between the plates give way abruptly, and the parts of the oceanic crust is then upthrust, resulting in displacement of a large column of water vertically. A marine volcanic eruption can generate an impulsive force that displaces the water column and gives birth to the tsunami. During a submarine landslide, the earthquakes, the equilibrium sea level is altered by the sediment moving along the floor of the sea. The gravitational force then propagates a tsunami. The most destructive tsunamis can be caused due to the fall of extraterrestrial objects on the surface of Earth. Propagation of tsunamis or tsunami waves. Gravity acts to return the sea surface to its original shape. The ripples then race outward and a tsunami is a result. As a tsunami leaves deep waters and propagates it into the shallow waters, it transforms. This is because as the depth of the water decreases, the speed of the tsunami reduces. But the changes of the total energy of the tsunami remains constant. With the increase in speed, the height of the tsunami waves goes. A tsunami which was imperceptible in deep water may grow to many meter high, and this is called as the shoaling. Sometimes the sea seems to at first draw a breath, but then this withdrawal is followed by the arrival of the crest of tsunami wave. Tsunamis have been known to occur suddenly without giving any warning. In some cases, there are several great waves separated by intervals of several minutes and sometimes more. The first of these waves is often preceded by an extraordinary recession of water from the shore, which may commence several minutes or even often hour beforehand. The figure on the screen discloses you how a tsunami takes place. In the figure 1, describes about an earthquake rocks the ocean floor and then displaces volume of water, pushing it upward. Then sets off an oscillation which develops underwater at a greater speed. Seawater is sucked back from the shore. The waves get bigger as water gets shallower along the coastal region. Now, we study the 2004 Indian Ocean Tsunami, which is a great Indian Ocean tsunami in this 21st century. Tsunami, or the arbor wave, struck havoc in the Indian Ocean on 20th December 2004. The wave was the result of an earthquake that had its epicenter near the western boundary of Sumatra Island in Indonesia. The magnitude of the earthquake was around 9.0 on the Richter scale. Indian plate went under the Burma plate. There was a sudden movement of the sea flow causing the earthquake. The ocean floor was displaced by about 10 to 20 meters and tilted in a downward direction. A huge mass of ocean water flowed to fill in the gap that was being created by the displacement. This has marked the withdrawal of the water mass from the coastlines of the land masses in the South and Southeast Asia. After thrusting of the Indian plate below the Burma plate, the water mass rushed back towards the coastline as a tsunami. Tsunami traveled at a speed of about 800 kilometers per hour, comparable to the speed of commercial aircraft, and completely washed away some of the islands in the Indian Ocean. The Indian Point in the north, in the Andaman and Nicobar Islands, that has marked the southernmost point of India, got completely submerged due to the tsunami. As the wave moved from earthquake epicenter from Sumatra towards the Andaman Islands and Sri Lanka, the wavelength decreased with the decreasing depth of water. The travel speed also declined from 700 to 900 kilometers per hour to less than 70 kilometers per hour. The tsunami waves travel up to a depth of 3 kilometers from the coastline by killing more than 1,000 people and affected the more than lakh of houses nearby the coastal regions. In India, the worst affected were the coastal areas of as well Andhra Pradesh, Tamil Nadu, Kerala, Pondicherry, and Andaman and Nicobar Islands. Dear students, in this video, earthquakes part 2, we have been discussed about the magnitude, Richter magnitude scale, earthquake zones of India, the effects of earthquakes, and tsunamis, as well as 2004, the Great Indian Ocean Tsunami. In the next video, I will be in front of you with the another important session, that is in geomorphology. Till then, take care of you from the corona. Stay home, stay safe. Thank you, Ananda.